Hello everybody and welcome to another E5 podcast. I'm your host Paul Meenan and today I am joined by my good friend...
I'm JW.
And...
David Watts, aka Spark and Ninja.
My tag team partners. We should call ourselves like... I don't know if you remember wrestling, but Demolition had this three-man trio. It was Axe, Smash and Crush. There's a bit of a reference for wrestling there because it's WrestleMania weekend while we're recording this.
It's tonight, isn't it? Everyone can watch it, can't they, tonight?
I don't know. I watched it last night. It was weird not having an audience because obviously we're recording this in lockdown at the moment. So chaps, I don't know about you. There's lots of interesting CPD occurring, lots of online training now, it would appear, within the electrical industry, which can only be a good thing. One of the more interesting things, though, we've been trying to keep up to date with all of these different technologies, these new EV stations, shall we call them EV stations, for electric vehicle charging that are coming out, and some of them obviously use this open technology. Others, John, it says it's electrodeless, but yet you still have to put some device into the ground, which to me would be an electrode, but apparently not.
Yeah, it's described as a probe of some kind, which doesn't have to be an electrode, but it's something else that goes in the ground instead. But quite what it is not clear yet.
A wonderful play on words then. So yes, the difference between a probe and electrode. So I think a lot of electricians, a lot of electrical installers at the moment, we're having some challenges, I think it's fair to say. Within electric vehicle charging, there are 4 modes. Again, this is the industry terms that we're being informed as contractors and installers. Mode 1 being a standard power lead, where you buy an EV car off the lot and they just give you an extension lead and say, yeah, just plug it in and away you go. And many people we've seen many cases on social media of socket outlets cracked, melted, and then people wondering why. And yet the British Standard for Socket Outlets clearly says it should be EV, not marked with a label, but it should actually come from the manufacturer made to do that. Most manufacturers now no longer use a mode 1 charging because it's really dangerous, because the lead is always live. So it's not a great mode. Mode 2 is also known as the granny lead, where you've got this electric vehicle control box built into the lead, and it generally limits the charge to 10 amp. And again, all the charging is done effectively inside the car, so the AC goes into the car and it converts to DC. Mode 3, which is the one that electrical installers, electrical contractors would be using. It's a dedicated box or whatever widget you want to call it. It's got all of the Type A or Type B RCDs normally built into them. Goes anything from 3.6 kilowatts, all the way up to 40 kilowatt and even higher for super fast chargers, Teslas and electric superhighway. But again, the charger in the vehicle converts the AC to the DC. So it's fairly evident that it's quite bespoke situation EV charging. Mode 4, the charger again is built in, but there's different types of socket connectors depending on the manufacturer. Currently they go up to, I think it's 50 kilowatt, but you can get higher, up to 120 kilowatt, I think Tesla are doing. So there's lots of different modes, there's lots of different plugs, and there's lots of different options, and there's lots of confusion. And I think it's fair to say a lot of electrical contractors, when they were registering for the OLEV grants, you were kind of registered with one manufacturer. If that, tell me if I'm going bonkers. Was it you were registered with one manufacturer? If you were with Rolex, that was all you installed was Rolex, and you got your grants, and that was it. That was all you used.
You pretty much kind of signed an alliance with them or something, and you have to kind of install theirs, and because I think they kind of authorize you, or they kind of give you access to the grant.
Yeah, which is kind of weird for me, because I have in my house, I've actually wired a 10mm radial for an EV charging point. It's called up at my board and under the floor, ready to go. But I don't want to be limited. When I do get a hybrid, which will probably be my first EV one, I will not want to be limited. I want to go out and find the best EV charging unit with the best technology in it, buy it and fit it myself.
Yeah. I think the thing is, we were introduced to EV mainly with the introduction of 722 back in the 17th edition, which was that 2013, was it? I think 722, the free download. So we've had access to the sector for such a long time, and way back then, mode 1, 2, 3, 4, these were all then as they are now. Obviously, we've started to see a little bit of an alignment to use some over the others. Obviously, as you said, mode 1's not very favourable at all now, really. But everything else has always kind of been a bit in the air because manufacturers have chosen different interpretations of the regulations, and so you felt as an electrician, technically the manufacturer should be relied upon. So it shouldn't be a problem for the electricians to just buy electric vehicle charging point and install it. But they all have different suggestive methods of installation. They've all got now upgraded methods of protection. We've seen a couple introduce new protection since the introduction of the 18th edition, and we've now seen a reprint of 722 in Amendment 1, which has slightly changed the original Unicorn device to suggest some more information. And there's been another additional 2 regulations on top of that, which John covered lovely in his video, where he basically said, the Unicorn is still a unicorn. I mean, maybe this new device John has got is like the first Unicorn because it needs those 2 it needs that extra reference to Earth, doesn't it?
You mean via the probe? I mean the electrode.
Yeah,
I mean
it needs
the
a probe electrode thing. That is the Unicorn. The other new one is that one that is the the voltage detecting, and then you've got the third option, the last 5th option now, which is anything that achieves the requirements of protection that the other 3 above it achieve, or the other 2 above it achieve. So it's still up in the air. And I think right now some of the devices on the market that you probably recommend would probably be one that complies with the 5th in that list, which means none of the actual described ones above, but one that achieves the requirements overall. So it's just still heavily in. It's still evolving. The way we're installing them is evolving still.
Yeah, that thing with it's now 5 items on that particular regulation. Yeah. It was 3 before, of which 2 were basically impossible because unless you've got a balanced 3-phase supply and all that kind of thing, it's not going to happen. But the other one, there is at least one manufacturer now has a thing where they've described it as a probe that you just shove into the ground somewhere, which allegedly measures the voltage between that and the circuit protective conductor.
That would be bullet point 3, is that correct?
Yeah, so that's what was called the Unicorn device. So in theory, it does exist, but how well it works and whatever else, of course, is currently unknown as well. And then the 4th one is very simple. It's just saying that if the voltage goes outside of the normal AC voltage range, either too low or too high, then it will disconnect, which is okay in some cases if you've got your broken pen conductor. Unfortunately, not in all cases, so it's not a whole solution. And then that 5th one, which is really something else. So that's really up to the manufacturers to do whatever.
Something that achieves all of the above. Yeah, and that 4th one, obviously, it's described for single-phase installations, but obviously as you've interpreted and others, when you have 3 single-phase installations that are actually, of separate phases side by side, and you have a broken pen feeding off of a 3-phase that looks like single-phase in an end consumer, you can have that problem occurring. So it really is hard to interpret, and I can see the struggle right now.
Well, I'm struggling to understand the difference between an electrode and a probe, because to me a probe, let's be honest about it, right, so let's be pragmatic about it.
Yeah.
Where I'm going to put my EV charger, there will probably be some flowers or something growing, a small bed of roses. What's to stop my missus going out one day, pruning the roses and then cutting this lead to a probe, not thinking it's anything other than a bit of garden wire? Yeah. And is there a difference between a probe and an electrode? Now, I'm going to have to Google that because, for me, the first time I heard of this Unicorn device, I immediately, for some weird reason, thought of the Never-Ending Story. I was thinking someone was watching a fantasy movie or something. Where'd they come up with a Unicorn device? It's weird. They might as well just called it like the Jesus device, for want of a better term. Do you know what I mean? It's just, I just thought, I don't like introduction of phrases for stuff that is yet to come, because I think it's a false economy. I think you're cheating yourself and you're cheating others.
I think it should be clear that it's not actually called a unicorn device in the regulations, but
Yeah, it's
wherever
very
you
true.
look, it's pretty much described as that everywhere else. So somewhere that has come from, and that now seems to be what it's called.
I think the history of the regulation suggested this would be a way to achieve the right protection. And as Paul's kind of stressed, I mean, the devices would have to have sufficient mechanical protection to maintain the integrity of any probe or electrode, whatever you want to call it. But I think manufacturers have looked at that and decided to be a bit more smarter than that. And they've obviously manufactured something beyond that and thought, well, we'll just look at obviously voltage monitoring. And there's obviously one of them actually measures. It behaves like an RCD, but isn't an RCD, where it has a coil around the conductors going through some clever electronics. A lot of this, unfortunately, is patent pending still. So you kind of like, well,
I think John, you've got some of the original in your collection voltage operated breakers. I think we should just adapt them.
Or the old VOE LCBs.
Yes, yeah. I think they should just get adapted, and you should put one in your house, John. Do a video on it and go, there you go. There's my unicorn device. It's only 70 odd years old, still working.
Because I say that is pretty much the same deal, other than it doesn't disconnect the protected conductor, but the actual principle of the voltage between the two things.
You've got to have that potential voltage, that dangerous voltage has to be reached for the device to operate.
So do we think possibly, just taking a small step back, that given what we know, and we have debated this before about RCDs and them only offering a level of immunity to a certain level of residual current or leakage current, do we think that it will become more of a debate and a topic for debate, that we will stop looking at earth leakage currents and be looking at more rising in potential or fault voltages?
I think, the reason we went from VOE LCB to RCDs, I think, was because it was obviously more suitable to monitor for leakage current over the presence of a dangerous fault to occur.
Well, yes, because
in the voltage. The issue here is the open pen.
But Dave,
the potential voltage rise on the ground.
But the VOE LCB, by the time it had tripped, you'd be dead, because it had to look at the two earth references and wait for it to trigger. Residual current was always a better thing to monitor because it was quicker.
Which is why it took over.
But now we have modern electronics. Now we have modern electronics who can instantaneously do it. So are we up for the idea of potentially that the debate around RCDs, we could potentially move away from RCDs and go back to a form of voltage operated earth leakage breakers to protect installations, because then you wouldn't have to worry about the DC leakage?
Yeah, I mean, it really depends on what you're looking to protect, because the old voltage operated ones from the 1980s only protected the installation, and that was their major problem, in that if someone grabbed hold of a live cable, it didn't do anything. It just sat there and didn't notice. It was only if you had a fault between part of the installation and the actual circuit wiring, then it would disconnect. So normally used on the TT supplies of old, but obviously the RCD is a different device, and that's only for protecting of people. So if you're grab hold of a live conductor, then that will disconnect in that scenario, whereas the voltage one didn't. But that was before TNCS supplies were common, and all of this stuff with vehicles and things being charged outside was even considered.
And that's the problem. Obviously, an open pen conductor is going to mean an LCD, as it stands, is insufficient protection now. And we can't convert to TT systems, obviously, with EV charging points, because you're going to be putting an electrode into an area where the mass of the Earth is most likely going to be electrode onto a PME.
So, that's interesting. So that debate, and I'm going to get slaughtered for saying this.
It's definitely, in my personal perspective, it's definitely a reach, but there's a plausible theory to it.
Yeah, no, and I've seen the theory, and I get the whole. Yeah, there can be a loop. I get that. So I've got a lead bitumen wrapped cable, which is PME'd. Now, you and I both know it's not PME'd in the street. It's PME'd at the substation, and that's it.
And those electrodes, even for a run, are quite sufficiently distanced apart.
Exactly. Now, I am actually going to put an earth electrode outside the front of my house, as you will know, very soon, and connect it into my installation to create a local earth reference.
Which, in the future, looking at our studies into Part 8, is likely going to happen anyway.
Well, yeah, that will then become my prosumer's earthing installation, won't it? So I'm actually going to be installing an earth electrode, which is for an experiment of a bit of kit, but it's actually going to become a future prosumer earth electrode. So I'll be able to switch out my DNO earthing and rely on a local electrode. And yeah, well, my driveway's breaking up, so it looks like I'll be getting a new driveway in the next 5 to 10 years as well. So
It's convenient.
it's very convenient. Well, sadly not, because I haven't got the money for it, but I'm going to have to do it. And if I'm going to do it, I'm going to do it properly.
You're going to get some earth grids in, or earth mats.
I'm going to put the rebar. I'm just going to go to a builder's yard and get a load of rebar and just lay it in and pour a load of concrete, and that'll be okay. So we've got these different mode chargers, confusing, different ways of earthing. We've got unicorn devices. This EV stuff is so prevalent, and this is, I think, Dave, if you remember when we were talking about what is an electrician, the amount of effort and energy to focus in understanding EV is massive. You could almost say it's an ism, a specialism to an extent. There's such a breadth of stuff here. And one of the things I want to start off by, so we're going to expand this debate and talk about something called V2G, vehicle to grid. Now, this is something that most people listening will go, vehicle to grid, what in God's name is vehicle to grid? JW's about to tell you. Go on, JW.
Okay, well, vehicle to grid is essentially where you have your electric car, which has a big battery inside. And that battery, of course, is a thing that can store a significant amount of energy. So rather than just taking energy out of the grid and sticking it in your car and using it, vehicle to grid does the opposite. So if your car's just sitting in the street and it's fully charged and you're not using it, if there was, say, a shortage of power in the grid, your car can then act as a power station, effectively, and put power back into the electricity grid to cover situations where there might be excessive demand or a lack of generation from somewhere else. So it's like a two-way system. So it's charging your car at certain times and then using it as a storage device at certain other times and putting it back in. And there may be financial incentives for people to do this. So you might actually get paid something for using your car in that way.
Sorry.
You're right. What are you doing?
That's my mic. My mic was playing up there. I apologise. So this vehicle to grid, John, it's fair to say, for anyone listening, always worthwhile doing your own research. So if you look at, if you Google V2GB, vehicle to Great Britain, it's actually called Vehicle to Grid Britain, and there's a report written by Element Energy. On behalf of Energy Systems, Catapult, Cenex, Nissan Technology, Moixa, Western Power Distribution, and National Grid. So it's fairly evident that this vehicle to grid has been a rather intense and thorough study, would you say, John? It's effectively smart chargers, isn't it? And what was the term that they use in the report again? I think it's a virtual power plant. The theory is it creates a virtual power plant. If you have all of these different people with cars parked up during the day, like your tradesmen or whatever, and they're plugged into the grid, you times that by, say, 50,000, transit vans, electric transit vans, you've almost got a virtual power plant connected in parallel with the national grid, which, if needs be, could be called upon.
Yeah, that's exactly it. So you've got essentially storage being put on the grid for the first time, because at the moment, for those that don't know, electricity that's generated has to match what's being used. So if there's a big spike in demand for electricity in the country, all that generation has to be found and matching it. And if it doesn't, then it all falls apart and nothing works. And conversely, if there's a big drop in demand, generation has to be topped off at the other end. So it always has to match. And at the moment, there is pretty much no storage. This creates a big problem, certainly with things like wind power, because at the moment you've got all the wind and if it's windy, lots of power coming in. If that wind drops for some reason, suddenly you've got a big hole there. You've got to find it from somewhere else. So this could be a way of sort of smoothing out those things and having a sort of on-demand power station effectively made up of, say, tens or even hundreds of thousands of vehicles.
If you think about it, that does add up to quite a large power station. So we've had, since 722 was brought out, they brought in the term, they used the term load shedding, which isn't this, which now has become, I think it's called, curtailment, load curtailment, which is obviously where we'll use technology to monitor to communicate with the grid, to then, when we plug the vehicle in at home, when there's large demands on the grid, obviously the grid will then tell the vehicle not to pull so much. And load curtailment's a great initial strategy. Load shedding is when the grid will just then shut down areas to in certain sectors or certain parts to then allow that demand, as John says, to go into the areas. Because power's not free, and it's always varying demands, and they've got to always find that energy. So if we have electric vehicles that are actually storing energy that are just gonna go home and spend a bit of time on the driveway before we then, everyone when they get home, they're gonna plug their vehicle in and leave it overnight ready for the next morning. That's the behavior of the person at home. They're not gonna plug it in and wait. If the battery's decided to stop, it's like your phone. You charge it till it's charged. You may not immediately unplug it. You'll leave it. And so they'll monitor those behaviors, and they will initially, if they identify that you actually go home, you plug it in, they'll then take that back and then charge you up again at night
smart,
time.
isn't it? Smart is
That's
doing the
it.
right. Smart is doing the right thing with the right tools at the right time.
So if all these vehicles will create quite a few large power stations, all spread around the grid, which is very good for the grid, and hopefully, with load curtailment added, just to protect the grid. This is what they're aiming for. It's like a combined force there. The charges and the curtailment to protect the grid from overload, and then when the vehicles are storing energy, let's give it back.
So just to read one of the interesting lines from the report, publicly available, vehicle-to-grid technologies, which infers there could be more than one, which we'll get onto, are expected to play a key role in the decarbonisation of Britain's transport and energy systems. If anyone hasn't realised, there's a massive push to decarbonise the UK and make us smart and as efficient as possible. It then says connecting millions of EVs, electric vehicles, and coordinating their charging and discharging would minimise the costs of EV charging whilst allowing the grid to balance the integration of high levels of variable renewable energy sources. It's a
couple of things with that. Obviously, help with the charging costs for the charge you're going to use. Because the charge you're going to use would be the one that's happening overnight when your rate is lower. With regards to decarbonising, that's not covered here at all. The power's got to come from somewhere.
Power coming from somewhere. We'll cover that a bit later.
Yeah, we'll get there. So that's not this. Although it helps as a key role, I don't know how how they can conclude that. Technically, if you're going to constantly charge it with some kind of large carbon emission, it's in no way decarbonising at all.
There'll probably be some sort of value add incentive. If this program ever takes off, it will be the likes of, like, say, the large fleet owners like British Gas or Tommy Clark's. There'll be an incentive for them that when they do go to their EV fleet, because eventually everyone will have an EV fleet, that EV fleet will sign up a contract to contribute towards a vehicle to grid market. There'll be a financial incentive for them, which will make probably the vehicles cheaper, will make their fees cheaper, so that they can actually start the practical study. Because remember something, when this starts, they're going to need case studies, small, medium and large scale, so that they can effectively tweak and develop how smart and resilient local grids are. Because grids are configured slightly differently depending on who the DNO or DSO are. So yeah, this is kind of a snapshot into the future, really, isn't it? Because you can see this being just part of that whole prosumer, the network prosumer add-on. Really, it's all one integrated system.
Yeah, we're saying there in the future, but EDF Energy, you can actually get this system from them now if you're a business, as they actually have it available. If you go to their website, you can actually inquire about this particular thing. And the idea is you lease an electric vehicle from, actually it's Nissan, I think, is the main choice at the moment. And they're actually saying now on their website, you can generate revenue to save on the running cost of it. And they're suggesting that revenues made through their V2G charging service are shared, and that reduces the annual cost of electricity. And they're saying, say, about 8,000 miles a year per charging point you eventually get for free, just for the fact that you're using your battery in your car as a storage device.
I think what we'll do, Dave, as well, is for people listening, if they look on our Instagram account, some of the pictures of these reports, like the virtual power plant images, and some of the charts, we'll put them on our Instagram account. For when people listen to this, they can look at some of the diagrams that we're looking at, like you'll see virtual power plant and all that, and the electricity charts and all that. So you've got a kind of an understanding. But I'm not surprised EDF are doing it. I used to work for EDF, Electricité de France. Interesting company to work for, actually. In all fairness, they weren't too bad. Could have been a lot for a big company. They weren't bad at all, actually. Normally, the bigger they are, the worse they are. But EDF actually generally, they were decent. They were a decent company. Right. Okay. So vehicle to grid. That's going to be a virtual power plant and a very complex thing. But EV in itself is really complex, really complex. So for those listening again, there is a World Electric Vehicle Journal, and there was a issue 26, September 2018. There was an article published regarding IEC and ISO standards and how we are adopting and choosing various standards for global integration of electric vehicle parts. And it's just a minefield, chaps. I mean, it's an absolute minefield. So I'm just looking at a drawing, which again we'll put on our Instagram page and on all the rest of it. And John, you can put them on your Facebook and all the rest of it. But just on the from the home to the car, I'm just going to list out some of the committees and various bits.
Okay.
So IEC Technical Committee 64 deal with the home. Okay, and JPEL 64, we know that. IEC Standards Committee 23B deal with the plugs, certain plugs. IEC Technical Committee 64 deal with the standard plugs that we know, which externally plug from a unit into the car. You've then got IEC Technical Committee 8, which then deal with the electricity companies and the national regulations and the connection back to grid. Another thing, you've got IEC Subcommittee 17D, IEC Technical Committee 69, IEC Subcommittee 23H, Technical Committee 20, you've got Technical Committee 21, Subcommittee 3, Technical Committee 22, Technical Committee 2, Technical Committee 105, Technical Committee 21, 106, 77, 23. It's insane. There are absolutely loads of different parts and components of what should be reasonably simple, trying to develop standards and then harmonize them across that, as we've discussed previously, that hierarchy of legislation. So as you've said in many a video, and Dave, you said in your webinars, that IEC standards, that global standards, then down into Senelec, and then down obviously into British standards. There is an insane volume of committees and standards and stuff that is still, if it's fair to say, still being developed, still being worked on.
Yeah.
Still, I mean, we talk within electricians, we talk 722, and obviously Amendment 1 was the update to 722. But Dave, John, you and I both know that there's more stuff now coming with more amendments. I mean, what's the one that I was talking to you chaps about the other day? Hang on a second. What is the standard? I can never remember the standard number.
Well, we've spent a lot of time digging deep. It's like a rabbit hole, isn't it? When you start going into these standards, you start reading information and they throw a number. I mean, how many times, if you guys listening to this, how many times you read a BS 767 on the regs, and you've just read a reg and there's this BS number thrown at you, and you go, oh, well, I'll carry on reading, and obviously that number can't hurt because it's just a random bit of nonsense in the middle of a paragraph. All of those obviously go somewhere. And a lot of that is kept well out of reach.
So just on that, IEC 61851-23, electric vehicle conductive charging system, DC electric supply equipment. There is also a British standard. It's 172 pages of misery, BSEN 62752, which was amended in March 2020. So the in-cable control and protective device for Mode 2 is a 172-page standard, which was amended in March. So does that have an impact on 722? Probably not, because 722 is so very much is the word light, kind. It's very light.
Well, very, yeah. I mean, it's literally a few pages. So what's in there is a tiny little dot compared to the actual huge volume of other stuff that's actually out there.
Again, I'm trying to be very kind. God bless you, John. Yeah,
I think the main push for 722. I mean, what's the biggest change in 722 or in Amendment 1? Sorry, is it the protection? Is it clarification on the protection requirements? Was there anything else that was really?
I don't think it's actually clarified a lot. It's just added some other options in, of which are wide open and sort of not really defined in any way.
Do you know what Amendment 1 to me was? Can you hold fire, chaps? There'll be more to come.
Pretty much.
That's kind of what it was. I mean,
because that regulation that was considered the unicorn that was rewritten in this one, but they added guidance in the annex that then added this mention of the electrodal probes. So it's like, oh, okay. So previously, this device could have been any device, but it maybe didn't mention voltage monitoring. And now guys have manufactured voltage monitoring. They made the univolt on device or that regulation now not quite applicable, but you mentioned these probes. And they've now created another regulation, but then they created another point, 0.5, which kind of basically is free license for any manufacturer right now.
Well, at the moment, I mean, I'm looking at two standards. So, IEC Technical Committee, if you look at IEC 61851-24, which is a standard that deals with digital communications between a DC EV charging station and an electric vehicle control.
It's this
of
stuff.
DC charge.
It's this stuff that's going to actually change it, as you say. We're looking a lot now at smart. We're looking at the car talking to the charger talking to the grid. These are the changes that will rewrite or rechange some of the ways that we carry out 722.
Very much so. Very much so.
And they're still in their infancy.
They are in their infancy, and that is the scary thing. I spent a good number of hours the other week looking up just what's in draft for public comment and where we are with stuff. And I think 4 to 5 hours down that rabbit hole, and it was like, great. So we know there's more, because eventually we've discussed this before. So if we just go back a step to when we did our future of electrical installation industry, and we talked about prosumer. Okay, we know that the revised 60364 Part 1, so fundamental principles in either Amendment 2 or Amendment 3 or the 19th edition, whatever they choose to do, it's going to get radically changed and updated. It's going to introduce the term prosumer, energy efficiency, smart, all that sort of stuff. So fundamental principles is changing to enable that.
And what's it called? Design considerations, wasn't it, or something?
Yes. So Part 6, inspection and testing, is going to be called verification, and Part 8, everyone thought it was going to be called energy efficiency, is going to be called design consideration, which is quite clever because nobody's going to argue with that term. Design consideration. And then when you open it up, it's about smart connectivity, energy efficiency, hopefully some really good stuff on design. I've not really seen it because, as we know, 60364 Part 8-1, 2 and 3 is all about prosumer earthing, switching out your earthing, enabling of smart monitoring of your systems.
They've got like energy efficiency management systems.
Yep.
Yeah, so there's lots of talk about management systems and smart systems.
It's one of the bits that John will never ever wish to comply with, because he won't want anyone snooping and monitoring his NASA-based rig that he's got set up in his shed. Don't worry, I won't be having a smart meter either anytime soon, although I will probably get forced to eventually. So yeah, it's getting more complex. I mean, John, what's your thoughts on it?
Yeah, I mean, this thing about the energy efficiency thing, or what's going to be Part 8, is going to be absolutely massive when it's finally put in there.
Yeah.
And it's going to affect pretty much every single installation. As it's not going to be some optional appendix piece that's stuck at the back. It's going to be part of the regulations, and it's going to have to be considered for pretty much everything. And in terms of electric vehicles, like I've got here, this is going to have a big impact on how they're actually charged, because at the moment the most common is either that granny lead, which quite frankly people shouldn't be using, or it's the plug it in the wall with the 32 amp thing. But the problem with those is that you're taking AC from a wall, and then the car is converting it to DC to put in the battery.
There's losses there.
Yeah, so there's quite big losses, whereas the DC ones, at the moment, it's a DC converter outside the car, and it's just putting DC directly into the battery. So in the future, if you had, say, a battery storage system in your house, something like the Tesla Powerwall, which is currently available, there's no point converting DC in a battery in your house or from solar panels into AC and then putting AC into another device and converting that to DC in your car. So I think in the future, DC charging for the vehicle is going to become pretty much the standard deal.
Well, if we're going to consider bringing in DC storage systems for any other purpose with prosumers such as generation, solar, and things like that, you'd have to keep that DC clean for electric vehicle as well, surely. You'd have to find a way to generate that capacity. You'd have to.
you're going to have some sort of some sort of DC power converter or stabilizer to make sure what DC you're using is regulated and stable. Otherwise, I'm sure the sensitivities of the connected equipment will not enjoy it too much.
It might be that, for example, it might be. I mean, we're talking right now about vehicle to grid, the idea of overnight actually charging it. It might be that they'll have an AC and DC charging system. Maybe we have a lead that is AC or DC. Where we can actually pull a heavier demand on the AC imported network if we have urgent charging, or we can plug it in overnight and have it trickled on a DC charge.
Well, that would be your single phase utopia, wouldn't it? So if
It
you
would
had a multi-pin plug where on one side of it you had a DC feed based on if you've got, well, let's say you've got a Tesla wall and a solar system and you're actually generating more than you're consuming, then naturally your bias would be to take the DC straight and inject it into the DC components of the car. And then the smart system to communicate and say, I'm full now, just keep it in storage or, do whatever.
But again, it's down to obviously smart technology understanding your behavior, or would the customer actually have that setting where they say, charge me in 2 hours, I need to go back out for dinner? Or would they say, charge me overnight and, smarter charging?
So look how many electricians now, for the last 5 to 10 years, electricians have been installing earth electrodes and rods to all these EV points. These EV points, at some point, when the cars get upgraded, you're going to end up having to upgrade the electrical installation for them.
They are, because a lot of these will be 10, 15, well, they're going to be 10 years old now nearly, and some will become 15 years old, and the technology's just moved on, and the cars will move on.
Yeah, they will.
There will be some will have to be changed.
And at the moment, your typical charging point, which is a Mode 3 charger, which is the one you screw on the wall, it's the 7 kilowatts or so. That is basically a dumb box on the wall that just puts AC out on the pins when it detects that there's a vehicle plugged in.
I love the way John puts that.
Yeah, it doesn't have any kind of fancy stuff in, regardless of the fact they're
right.
500 quid. It is literally just a relay inside that turns on the power when the car's detected. So it's not a particularly intelligent device.
Some manufacturers may call it a £500 box of happiness and joy. Some may call it a £500 box.
I'm going to quote JW on an Instagram post, a picture of an EV charging point. John Ward. A dumb box on the wall, 2020.
A dumb box on the wall. So can we now agree that we'll set up a company called the Dumb Box on the Wall, and we'll just get some cheap plastic boxes, and we'll literally just put a Type A RCBO in, and just put a fancy looking plug on it, and job done. And then if people want a lead for it, we sell it to them at £400 on top.
The thing is,
a dumb box on the wall, John. Copyright John Ward Enterprises. Love it.
We're talking about obviously these technology changes and the need for us to look at these. But when you look at how electricians who are trying to, the industry is saying money making, make money now. Training companies are selling training courses on subjects that they haven't even understood yet because the guidance book hasn't even been published. But they're delivering courses on a subject that is changing every single month to tap into funding to push and drive a market. And then the people who are actually registering to this, all I'm hearing from them is it's not worth it because the paperwork is an absolute minefield.
Yeah, paperwork has become I'll be honest with you. Do you know what worries me the most is, I'm looking, because I'm quite sad. I'm looking at an IEC stand, which we'll talk about in a minute, and it's heavily electronics and communications. Heavily.
Makes sense.
And sadly, a lot of electricians, as we know, your electronics, you print. For me, electronics. Yeah, I learned it in my college years, but I didn't leave using it that often. In all fairness, I'm really hoping now in the modern training organisations that the learners, when they're learning their electrical science and principles, that they are actually really retaining it, because it's fairly evident that most electricians that are kind of getting into the industry now, it needs to be cruise control for them to be able to say, I need to, when I come out my time to be diversifying and getting into smart home, smart install, comms, I need to know Cat 5, Cat 6 off the back of my head. I need to know all these special plugs, adapters, leads. I need to understand this.
I've said very similar this week in webinars that I've done with my father. We've been talking about FE training. Talked a lot about FE training because we can see the apprenticeships that are still delivered today. There's, again, environmental legislation was one update, but the actual outputs of that are still not clued up. So they'll either go on, modern apprenticeships, or they'll go on to electronics, but there's nothing that combines them all effectively. But you're right, it needs to be rebuilt and structured so that the guys on the outputs of their apprenticeships are actually very technical savvy, so they can carry on picking up and basically every other month relearning some technology, because this stuff is changing so rapidly now. These manufacturers are testing things, and then the regulations are trying to catch up, and then training courses are trying to catch up to the regulations, and so the manufacturers are always so far in. How many times have we said about manufacturers having to set levels for training, manufacturers having to get involved with more time in the colleges and things? There's reasons we've been saying that. It's because people are so far behind.
Yeah, I think it's evident the manufacturers are not going to have to just go in and do a hearts and minds exercise. They're actually going to have to go in now and give some real transparency on how to adopt the learning of this material. I mean,
the thing is, I've observed a lot. It just recently, obviously, we had lots of webinars this week, and I've quite tried to listen to manufacturers, and a lot of electricians, they don't quite want to listen. Or they don't know the importance of listening to them. Sometimes they often want to know, how much is it, or does it? Can I? If I do this, can I then do that? So there has to be this part where they're encouraged. Electricians are encouraged to seek more knowledge, more understanding, and then the manufacturers are just then offloading it, and then everything will actually start to improve, because this stuff is just going to get smarter and smarter to the point where we're going to feel out of our depth.
Well, yeah, tell me about it. I sometimes do feel out of my depth regularly.
We are forcing ourselves to read things that we wouldn't dream of reading a few years ago.
Yeah, the stuff I've got on my screen at the moment is just blowing me away.
The thing I'm looking at right now.
Formulas.
This flowchart I'm looking at right now, only by starting an evening discussion with Mr. Pullman and John Wood would I now be looking at this thing in front of me, this flowchart. And that's the point, many people won't be doing this.
Oh wow! I tell you what, I'm looking at a chart that has the wake up signal, sleep signal, communication signals, alignment. Oh my God! Safety monitoring, diagnostics activated, power transfer enabled, disabled. Oh yeah, EV device state diagrams. I'm looking at the moment. This is getting so complex, so complex. And on that complex, there's a reason why we're talking about this. It's more of a heads up, really, isn't it, for folk listening to try and it's going to get harder. We need to do more small bite-sized CPD. We need the manufacturers to take us on a journey. At the moment, the manufacturers are only taking us on a journey, which is understand our box of junk.
Yeah, it's mainly understand how we comply with BS 7671, because that is, as I said in our presentation with the future, that is all we're looking at. We're focusing on 7671.
Yeah, but a lot of electricians, when they look at this new stuff, they'll want to turn around to you and go, "How do I fix it to the wall? And what do I need to wire to it?" Yeah. That's what Sparks do, and to a certain extent, that's all Sparks want to do.
Indeed.
So, who is going to do all of this work to help make the electricians' lives easier when selecting and erecting, or is it just going to be you have to align? I mean, I think me and you have discussed this before about, are you eventually going to have electricians who are bespoke trained and aligned with protection? So, for instance, Schneider, electricians that only install Schneider because Schneider trained them, they develop them, they enhance their skills and knowledge. They use WEA tools because they're the ones that show them new products, new developments, and they buy them at a discount. So they're aligned with those. Well, corporate.
We see that today. Take Dan Jackson, for example.
Yeah.
I mean, I can complete an apprenticeship. Dan will complete an apprenticeship.
Yeah.
Dan then ends up working in a specific sector.
Yeah.
Where he's regularly reviewing manufacturers of that sector. But we initially had the same starting qualification, the same whatever you want to call it.
Yeah.
So we could both apply for the same work. But because he's demonstrated regular CPD and monitoring in that, he's become very competent in that sort of sector. So you're right. We are going to get to a point where, unless we start, again, this goes back to the whole drive of license to practice and CPD monitoring. We need to find ways for the electricians to be offered free or well affordable CPD in the areas they're going to work in. Electric vehicles, if they're going to keep changing the technology, we need to just have access to it. And a lot of us can find it if we dig deep for it. And we're having to dig really deep to find some of this stuff. Really deep.
Oh my God, deep is
really deep. And that's the thing. We're having to go. We're having to go abroad in some scenarios to see what's going on. and stuff refers back to the UK. You know, we don't see that stuff in the UK, but we see it in abroad, and that's the point. Electricians, you're right. Right now, they do just want to know how to install it and how much it costs, and that's fine as long as they've got the competence. But when we say what competence is, you can't say competence is there unless electricians have that support by the industry to maintain that competence.
That is key. And in all fairness, in this lockdown, I mean, there's a really good. We've got to give them a shout out. There's a really good Twitter account called Free CPD.
Calendar.
Yeah, the CPD calendar, and he's developed that from nothing, and it's fantastic. I mean, I looked at it tonight, and there's like on Monday, there's like 9 free CPD opportunities. Fantastic.
Some people just don't know where to look.
Well, and that's the beauty. Something
That's
so
it.
simple, and it's just drawing people in and giving them the ability. I mean, I'm working still, as you know, full time anyway. So it's great to know that there's stuff that I might be able to get an hour out to log into or register to. And I think Schneider are doing, obviously this will be done, but they're doing one on fires and electrical installations this coming week and all sorts. So it's fascinating to see what's actually up and coming, for want of a better term. But
and hopefully some of the guys will kind of, you know, carry on this. You know, once they realise how easy it is to tap into CPD, they'll get it. You know, we just need to kind of get them to understand what CPD is better. Well, you know, we uploaded our podcast today. This one's going to go up late, but the day we were recording this, we uploaded our podcast on CPD, didn't we? That went out today. So had some good comments about that on Facebook today.
Did we? Oh yeah, we did. Yeah, sorry,
this morning,
Sunday,
sometime.
isn't it?
Yeah.
Yeah, the CPD one. Yeah, we recorded that weeks ago. That was before,
Yeah, that's the point.
before the lockdown, actually.
We did, yeah. But I had some great comments on that already, because it's you know it's hard to actually interpret it.
Yeah, I've not checked. Sorry, Dave. That's my bad. I didn't. Yeah, the trouble is I set them for 5 a.m. to release on a Wednesday and a Sunday while we're in this lockdown thing, and I just don't bother looking. But then again, I've been busy doing gardening and stuff. Right. Moving on. So it's fairly evident that this is, well, life's getting more complex, but this EV thing is potentially going to get more complex. So it'll be interesting to see anyone from JPEL who might be listening. We are watching to see how you interpret this massive data coming now on that. Future technologies, because EV isn't just about plugging your car in at home. Now, if you look at, there's a British standard, sorry, I'll rephrase that. There is an IEC standard 61980-2, which is called Electric Vehicle Wireless Power Transfer System.
Let's just remind people, what does IEC mean?
International Electrotechnical Committee.
So is that British?
No, that's global. So these are the people that write the global standards. So this is America, Asia, everybody basically that sit in these meetings and they discuss stuff.
Yeah.
And they now have, under a British standards publication, published document IEC technical specification 61980-2, published 2019, and it's electric vehicle wireless power transfer. So this is the stuff buried in the roads.
The inductive charging.
Hang on. I know I haven't read it yet. I believe.
Is it?
I haven't read much of it yet.
It says wireless in the title.
Yes. Yeah. It's wireless in the title.
You're going to assume it's inductive, or what else could it be?
Electric vehicle wireless power transfer. So this is the one that deals with the plates that go into the ground. John, we were talking about this earlier on, weren't we? There's like a weird antenna type thing.
Yeah, I mean, it's similar in principle to the wireless charging you get on certain mobile phones, where you put it on a little plate and it charges it without actually plugging in. But unfortunately, of course, for a vehicle, it has to be scaled up a massive amount. So it's a big coil in the road, matching coil on the vehicle, and the power is transferred between them.
So like some of us might have this little charger pad in the car. We just rest our phone on it, or one on the desk, charges our phone. And this is the same thing where we place our car, we park our car onto a pad, and it charges the car. Is that the theory?
Effectively, yeah. It's that little wireless charger.
Isn't that going to require quite a high amount of power or quite a high frequency to operate? I mean, I don't know.
Well, yeah, it certainly is, and this is one of the problems with it, in that the frequency of the coil is not going to be 50 hertz for a start. It's going to be much higher, because otherwise it would be massively inefficient and it would hardly even work. And then you've got all kinds of other problems about how is it going to be activated, and is the distance between the car and the thing in the road, and all kinds of other factors which probably haven't been thought out yet.
But obviously, if this was actually integrated and then put in, you've got rid of the cord, which when you see some pictures of these pillocks and they're parking their car and they're just putting a cord across the path, there's clearly a safety. There's a thumbs up for this technology to be pushed in probably some big built-up cities, places where any cords aren't a good idea.
Yeah, that's it. And the idea is that you just drive over this particular pad in the parking space, and that's it. It just does all the rest for you. So.
Yeah. So for those listening, there's some terms that probably people should be familiar with. So there's the 4 modes we were talking about are called conductive charging modes. Where obviously you use literally a conductor to plug in. This is what we're talking about here is wireless charging. So this is again a box of rubbish on a wall, maybe somewhere, which is owned by the council or installed by the council, and then there is literally something that the
so
car.
It could be a cable going under the ground, buried to a plate on the floor.
Yes.
Okay.
And there is So there's a couple of standards. 61980-2 and -3 are kind of the principal standards that we can see. Now, this is not for cars, just to be clear, this is not for cars that you can drive down a motorway while charging. You're better off having a car with like regen braking and stuff. This is a little bit more, this is just stationary. Now, I haven't read the standards, I'm going to confess. I don't mind having a little pad to charge my iPhone. I don't know if I'd want a fast charge pad outside my front door, pumping out radiated electromagnetic fields for things to walk along and charge. I mean, again, this is purely hypothetical, but if I lay my phone down, when it charge my phone, do you know what I mean? The principles are the same. At the end of the day, these phones, they've got systems built into them that pick up on that electromagnetic field and convert the energy into battery storage.
I saw a guy do a TED talk just not long ago, and he was saying we should turn off our Wi-Fi off at night, and we shouldn't have our phone near our bodies when we sleep. I've seen.
Yeah, there are a lot of people that have my phone on airplane mode.
Yeah, there are a lot of people who actually shout out about the dangers of. Is it radiation, or is it what is it? Is it the waves? What you've read up on this, Paul?
Electromagnetic field. So the first thing. So yeah, I mean everybody's panicking about it now at the moment because everyone's blaming coronavirus on 5G and all the rest of it.
Oh, I've seen the 5G stuff.
It's
crazy.
It's just madness. There is electromagnetic fields have always had the potential to be dangerous ever since electricity was invented. If you go up the bandwidth for frequencies used, you go up to X-ray, gamma rays, and all sorts of weird and wonderful things. There is let me get this right. There is an International Committee for Non-Ionizing Radiation, ICNA, and they have been around for nearly 20 years because I first heard of them when we were doing Crossrail about 15 years ago, and we had to put a substation next to a primary school, literally next to a playground. And in the specification, it said you need to do something called pre and post emission testing. So I'd never heard of this. I was like, what's all this about? And I did some reading, and it was literally, they produced some guidance. They still do produce guidance, and they're kind of like a watchdog or a body that says, look, don't put in substations near schools because people who are young or are still growing and developing, if you subject them to large radiated electromagnetic fields, it can over time cause harm, cause danger, and obviously a huge substation, not really a good thing.
Yeah.
So we ended up moving it. We moved the entire location of the substation, which was good. And the only time I really noticed was when we did the pre-emission testing, which for those who've never done any electromagnetic field tests, these guys turn up from like EMC specialists because it's all part of the EMC family, which is electromagnetic compatibility. And they put these things that look like Freeview aerials up around your site. And what they do is they literally measure the invisible electromagnetic fields that are in the environment. So they will pick up everything from digital freeview transmissions, analog
So
transmissions.
is this radio waves?
Yeah, radio waves.
And microwaves, because obviously that's
Yes.
the longer
Yes,
wavelength,
this is
isn't it?
anything that is transmitted on any form of frequency or bandwidth, even normal radiated emissions from the planet. Everything is picked up by these super sensitive devices, and then they can actually analyze them. And the pre-emission is to take a baseline reading. So there's something called the EMF directive, which is a European directive. We also have a UK directive as well. And these directives are about protecting people from long-term exposure from radiated emissions. So industry best practice 15, 20 years ago was to basically get a baseline data check, very similar to doing an earth loop impedance before you change a board. And you would then do a post-emission test check. Now, what you should find is your substation, wherever it is located for the best position, but the furthest away where it could do any harm to vulnerable persons. And that's what we found. We actually found putting this substation for the tunnel boring machines, it did cause a slight raise in elevated emissions within the area, but nothing that could cause harm to youngsters or other people. Saying that, I've met many electricians who've worked in National Grid who have all developed cancers. They haven't had very long careers. But again, it depends on the person's makeup. It depends on the transmitted waves. I mean, it's the exact same principle of LED. You know, some people can walk into a room and they'll go, "Oh, my eyes are hurting. I'll get a headache."
Yeah.
And they can see flickering. They can see strobing from the lights. But everyone else in the room looks at them and goes, "You're mad," because they don't see that particular frequency of light. And this is the problem. It's the stuff you can't see, you can't touch, you can't smell. It's really hard to actually know there's a problem. Look at earthing and bonding. We know that earthing and bonding in certain locations is a major problem, but unless you physically measure it and detect it, it's not a problem. It's only a problem when you actually go, "Oh, I've got lots and lots of energy or power on my earthing system that shouldn't be there," because my earthing system in theory
That's the
should
key
be
word,
benign.
though. That's the key word to say. I mean, this is all energy, isn't it? You
Yes.
know, it's all a form of energy, and that's the problem. It's it's quantifiable.
Yep.
And when we start messing with it, or we start generating, we've got to try and use it to power an electric vehicle. That's going to be. I can't wait to see what they create as to how they intend on doing it. I'm going to do some CPD on it just to kind of see if I can come up with some examples.
Just to give you
case
some
studies.
background on this, Dave. So June 29th, 2013, the European Commission repealed a directive which was created in 2004 and published a new directive on the minimum health and safety requirements regarding exposure of workers to the risks arising from physical agents, which was electromagnetic fields. It basically required well balanced, proportionate. It gave you a framework of what exposures to give to people. The HSE have got their own entire page on a guide to control of electromagnetic field at work regulations. In fact, there is an actual directive called Electromagnetic Fields at Work now, and it's a guide.
Can you copy that for me in WhatsApp? I'm going to read that later, mate.
I'm going to send it to you right now. It's 32 pages. HSG 281. For anyone who wants to Google it, it's HSG 281.
Yeah.
And what it does is it explains the employer's duty under the control of electromagnetic field at work regulations. Again, it's that invisible stuff, low exposure activities. There's lower level limits, there's upper level limits, there's assessments, there's vulnerable persons, there's a need for risk assessments, use of MRIs, working around that sort of stuff, health surveillance. Again, it's just, it's one of those pieces of legislation that nobody really reads that much.
Well, for the benefit of you listeners, this is something we're going to be reading up a lot on, so you'll probably get a podcast on it soon. Just
to kind of summarise, without us trying to sound like we're talking out of bollocks, an EMF, electromagnetic field, is produced whenever a piece of electrical or electronic equipment is used. EMFs are static electric, static magnetic, and time-varying electric, magnetic, and electromagnetic radio wave fields with frequencies up to 300 gigahertz. Electromagnetic fields are present in virtually all workplaces, and if they are of high enough intensity, you may need to take action to ensure your workers are protected from adverse effects. And it then says, and this is me reading directly from the guidance, exposure to high levels of EMF can give rise to effects that may be irritating or unpleasant. It then says EMF at different frequencies affect the human body in different ways, causing sensory and health effects. Okay, which can cause health and safety hazard. And then you can have indirect effects, so sensory effects, nausea, vertigo, metallic taste in the mouth. That's every time I drink cherry Pepsi. Flickering sensations, health effects, micro shocks. How many people get micro shocks? MRI scanners. You go on railways. Whew, yeah. Nuclear magnetic resonance spectrometers, electric lifting cranes. You can get them in. So just on the 1 hertz to 10 megahertz, you can get interference with active or passive implanted or body-worn medical devices, sparks caused by induced fields, triggering fires or explosions, nerve stimulation, effects on central and peripheral nervous system, tingling, muscle contraction, heart arrhythmia. Yeah, it can get. It has different. You've heard there's terms now where people almost think they've had electric shocks, or that was EMF sickness. There's that term that's come out recently, where people who genuinely think that if you hold your phone for like 10 hours, your phone, you'll feel like it's cooked. It's because it is being cooked by EMF radiated fields too close to it. So there's a whole guide on what the law says, and it says assess the levels, ensures exposure is below exposure limit values. Determine a plan. Most employers don't do this, by the way. It's only the big employers that do it. But it's a duty of care. Fascinating little one. I'll send it to you now, by the way. So yeah, if anyone's listening, please feel free to download it. Right, last bit. John, 2018. We've got all these standards. We've got all this complexity. Something's got to give. Do you think we can do any more to help the grid? Or do you think the grid needs to do some more to help us?
The grid in its current state is not going to cope with all of these things which we're piling in and obviously introducing, which is kind of why this vehicle to grid thing will certainly go some way to provide a bit of storage, because storage is what's really missing at the moment. And the other point here is where does electricity actually come from? Because it's very tempting to think, electricity is some kind of unlimited resource that just turns up in your house and all is well. But of course, all that has to be generated somewhere. So the question is, where does it all come from? Now, certain newspapers, which we won't name here, I'm sure we can all guess which ones, all like to put things out saying, oh, look, we haven't used any coal generation for the last 2 weeks and all this thing, as if this is some kind of big deal. And it's not actually wrong. However, the reason we're not using any coal to generate electricity anymore is mainly because most of the coal power stations are closed, and those that are left are in the process of closing, so we haven't got any left. However, what's happened is that whilst we got rid of all the coal stations, most of them have been replaced with gas power stations instead. So we're still burning fossil fuels, and certainly last year, about 40% of electricity in the UK came from burning gas. So this thing about, it's all being green and nice, not really quite as true as it might appear. And certainly if you're going to have, say, electric vehicles, at the moment, if you charge your electric car, a big chunk of that is coming from burning fossil fuels in a power station far away.
Well, that's interesting.
So do you think that a lot of the power that we're assuming right now is going over to renewables is actually just switched to gas? And it looks like, whilst, yes, we're not using as much coal, we've just switched to another fossil fuel for the majority of it. Yeah,
pretty much. I mean, at the moment, say 40% is from gas.
Right.
In terms of renewables, most of it is wind. It's about 21% comes from renewables at the moment. The bulk of that is wind power. The main problem with wind power, of course, is it's not windy all the time. So if you look at it on a woolly windy day, you might find there's a huge amount of wind power being generated. Conversely, you can look on a day when there's no wind, like there's big regional high pressure over the UK, and you'll find that wind generation is just a couple of percent. And the sort of remaining part of that is made up by gas. So as wind output falls, gas generation increases to match. And the rest of it, nuclear power's roughly 20%.
John, it's worth for those listening to us going, John's going off on one. Where's he getting all this rubbish from? The fairies? No. So the Department for Business, Energy and Industrial Strategy, or the Office for National Statistics, have published, God love them, a digest of the United Kingdom energy statistics for 2019. And if it's 182 pages of soul-destroying facts and figures, whoever wrote it, I doff my cap to you, because Wow, what a report. But one of the most interesting things, and again, we'll screenshot this and put this on our Instagram page, which everybody will look at and go, what the hell's that for? There's a fascinating electricity flow chart for 2018's statistics, and it's a very good visual diagram of how all of these renewals and everything interconnects. But the scary thing is, so this diagram is in terawatt hours, which is quite a lot. And on this diagram, 5 terawatt hours in 2018 were used in transport systems, so railways, etc. But the most interesting part of this is where it says conversion, transmission, and distribution losses amount to 392.2 terawatts
Losses.
in losses, which makes the transport industry just look like a fart in the scheme of things. It's just so disproportionate. I mean, Christ, the energy industry use alone, just for their own usage, is 25.8 terawatt hours. But all the rest of it, it just looks like short change. Domestic use, 105.1 terawatt hours for the domestic use of the UK. Okay, 5 terawatt hours for transport, 90.5 for other industry. It's mind-blowing. It's a fascinating flowchart. So again, John, I'm going to be really controversial, and I want you to disagree with me if you want to disagree with me. That says to me, again, as a simpleton, that the national grid can't or don't want to manage their network infrastructure, and are either allowing these losses and forcing us to adapt for their losses to ensure their capacity and resilience in their grid, or they desperately are struggling to cope and manage with all of these influxes of new technology and new systems of generation.
Well, in terms of those losses, the vast bulk of those is because we're burning vast amounts of natural gas and other fossil fuels. And of course, when you burn gas, huge amounts of that energy is poured away as heat. So if you've ever driven past any power station, you'll see there's massive cooling towers which are pouring heat into the atmosphere, which is just complete waste. And in terms of national grid, losses in the grid are about 7% of everything that's generated, which is equivalent to Drax Power Station in Yorkshire. So if you think Drax Power Station there does about 7% of the UK energy, all of that energy is going to waste in distribution, which is losses in transformers and cables heating up and all that kind of thing. But the vast bulk of it, which is over half of all energy, is literally thrown away just because most power stations in the UK work on steam, which is both heating up water, steam drives turbines, that generates electricity, and around a half of that, roughly, of that heat energy is just thrown away. And whether that's coming from gas or nuclear stations or what's remaining of the coal or burning anything else, that's where your wastage is coming from. And the only way to get rid of it is to not generate power in your traditional power stations.
Well, that sucks.
Yeah, I'm blown away. So you've probably, now we're at the end of this podcast, by the way, you're probably realizing that there's a whole bigger world out there. And it's one of the reasons why we thought we'd debate it and just record it as well, in all fairness, because it's currently melting our brains, the statistics and the volume of information that we are collecting and trying to understand as to what the potential impact to our industry and our trade will be. Because I've said this for a while now, and I'm going to stick by my guns. I think that the electrical industry, the consumer or prosumer, is being forced to adapt and mitigate for the lack of investment in our national grid infrastructure, the lack of management in our national grid infrastructure, potentially, possibly. But if you think for 1 minute that when the next amendment comes out, it's all fine, or the 19th edition, it'll all settle down, not a chance. For the rest of our career, all we're going to be seeing is more and more homes become smart, coordinated, producing, prosuming, earthing challenges. It's going to get more and more technical. Would you agree, chaps?
I would. I mean, I think we're probably 10 years away, not even that maybe, from the new home having what we thought we would see in that prosumer presentation we've delivered, where we have, at least two sources of renewables in the home, the foundation of the electrode, obviously no solid fuel burning for gas or heating, Although we did see on the webinar there's talk about hydrogen, which was interesting. The interesting part for me really is I can see that, and I can see why. I can see the national grid being basically really relaxed in its demand. We're going to, all companies can be pushed to prosume.
Well, you can almost see the national grid acting as almost a backup for local production and management, can't you?
The other way.
I think that's their utopia, isn't it? Is don't rely on the national grid. Go, if you can get off grid, great. Whereas you're not going to be able to in the cities. So focus on the cities, but in the urban areas.
And if you think about it,
we'd do it.
When you look at this flow chart, why would you? And if you wanted that output, you wouldn't want to fix the grid, because this flow chart shows you the grid right now. The idea of obviously converting and transmitting, there's so many losses in that method, and you can't really improve that with the way the national grid is made up.
No, the main
you can't change it.
Yeah, the main issue here is that if we want to decarbonise this, you've got to get rid of the fossil fuels. So that means getting rid of gas, which at the moment is 40% of all electricity.
Yeah.
But if you get rid of it, you've got to replace it with something else. And at the moment, the only realistic thing you can do it is individuals basically generating their own power, storing it locally, and using it locally. Because the only other viable option for large-scale power, unfortunately, is nuclear. And whilst that's viable, it takes so long to build new power stations.
Yeah.
I mean, at the moment, there's one under construction in the UK, which is Hinkley Point, but that's a decade away from being online. And that's just one. And by then, probably half the others will have closed anyhow. So
I reckon that'll be the one that's the main source, and they'll shut down the gas and the oil and the coal. And I hope by that time that a lot of us are prosuming. Hence
the rise of the prosumer.
Yeah.
And on that bombshell, gents, as always, I love yous dearly. I'd hug you if I could, but I'm not allowed to, social distancing. Chaps, final thoughts, and then we'll take this home.
My final thoughts are we are going to be learning more and more things every week. And everything's going in the direction of prosuming. And we're going to learn more about it. And we're going to have to keep updating what we present to people on it.
Yes.
Hopefully we'll start to be presented it. That would be nice, by someone else, so we can actually, hear it from other people.
That would be nice, wouldn't it?
It would be nice, wouldn't it?
Yeah, because by the time everybody else starts talking about prosuming, we're going to be like, oh yeah, we're past that. We're on to something else now.
It'd be nice to kind of hear other people's opinions, their research, and fundamentally, where their resources are, so we can see what else other information we can find. But unfortunately, I get the feeling that this isn't a random thing we can talk about. I think this is going to be something that's going to be in the background forevermore, as you say, moving forward.
Well, yeah, if EDF are doing it already on certain things, I think, without
doubt. To grid, yeah.
It's definitely... John, final thought?
Yeah, I think all I'll say is that anyone who thinks that the wiring regulations are going to suddenly get nice and easy and things are not going to be updated much, think again, because what we've seen so far is just a tiny bit, and they're going to get far more involved, far more complex, far more stuff to think about. So try and get ahead of it now before all this stuff piles in the next amendment and the 19th edition, and who knows what after that.
How on earth will they keep that to a 3-day course then?
Well, they're not.
You're just being cynical. Just remember, you won't need to if you buy John Ward's box of rubbish.
John Ward's box of rubbish.
I'm sure John will make them available for 199 of the Queen's pounds, and you too can have a box of rubbish screwed to your wall. John, I have to say you've made the podcast for your box of rubbish. Right, gents, thank you very much. And thank you, everyone, for listening. If you like this and you haven't fallen asleep, please like it, share it. We are grateful if you're listening. Please feel free to message us, info@e5group.org.uk. If you want to come on, please come on. Any feedback at all, just let us know. And thanks, chaps. And until the next one, take care of yourself and each other. Bye-bye.
Bye.